So I wanted to make a video to review the area model that we talked about during the week of the 14th of October. And so, but I felt like I didn't want to borrow new stuff. So this is stuff from your materials. It says you're supposed to be writing these pictures. And so the first thing is we want to look at what is the product. So in this problem, I'm taking x plus 5 and multiplying it by 2x plus 3. And I can fill in the inside of this box like an area model, so like a multiplication chart. So 2x times x is what goes here, and that's 2x squared. And then 3 times x is what goes here, and that's 3x. So it gets really choppy when I try to do this. So this is 3 times x. Let's just go a little slower. This is 2x times 5, and this is 3 times 5. And so 2x times x is 2x squared, 3x, 10x, and 15. And then we write it out as a product, 2x squared, as a sum, 2x squared plus 3x plus 10x plus 15. And actually, yeah. So that's for just a minute. And so then we're going to combine our like terms. It says combine like terms when possible, and these two are our like terms. And so my final answer is 2x squared plus 13x plus 15. And my plus signs and my x squareds keep running together. So there. And so that's it. That's the whole process. So I've covered up this one, and I really don't want it to be covered up, but I wanted us to kind of see this before I moved on. So I'm actually going to do a couple more. We'll do B and C, and then we'll move on to some other examples. But I wanted to be sure that we kind of got this. So just to make it a little bit easier here, we're going to play a quick game. Not a game, just get this. And then I can clear that up. And that way this is still here. Don't want to get rid of it, but it's not in my way the same way as it was a minute ago. So anyway, let's do B. And so this one would come from 3 times y plus 5. And we already kind of know how to do this with the distributive property that we learned before this class. But they're asking us to use the area model, so we'll go ahead and go slow. 3 times y, 3 times 5. And so my answer is 3y plus 15. And that's it. So those are the two things they're looking for on this. The hardest one here is C. I'm not going to do D is silly. So, but C is more interesting. So C, we have negative 7 plus 4y times 6y plus x plus 1. And on this one, I'd like to go a little faster. So 6y times negative 7 is negative 42y. X times negative 7 is negative 7x. 1 times negative 7 is negative 7. 6y times 4y is 24y squared. X times 4y is 4xy. And 1 times 4y is 4y. Excuse me. And so now I've finished the box. So when I look at my box, I want to look for things that might be considered alike. So I have these two that are alike, and that's it. So just something to keep in mind. So I'm going to go ahead and write my answer down. I have 24y squared. And then I have 4xy's. And then I have this one and that one. I'm just going to write them next to each other. 4y minus 42y, then minus 7x minus 7. And these two can combine. That's it. So 24y squared plus 4xy minus 38y minus 7x minus 7. And nothing else is a like term, and so that's it, and I'm done. Now there are other ways to do this, but the idea here is to focus on the area model. Now with question B and D, if you don't need an area model, that's okay. So let's look at a couple of more examples. So this is how the problems will present themselves on a test. or a quiz or a math problem in another textbook, or, and it'll say multiply. And so we are, again, using area models, which is highlighted right here in this word. And so we're going to use an area model. Now, the hard part is trying to decide what size the area model is when it's not given to me. So I know I have 2 by 2. And so what I like to do is kind of draw x plus 1. And then I need to do a line like that. Then on the top, I'll put x plus 2. And a line like that. And then I'll stick a box around the edge. And that's what I'm looking to fill in. And I don't feel like I should really be doing any more of these examples. Like this one, I would have 3, no lines to draw, 2x plus 5, 1 line to draw, and so my box will look like this. So I kind of put the box on at the end. It's just an easy way to figure out what size the box is. So this is the basic idea of an area model. It helps us handle what's known as, it's just the distributive property, but it helps me do this distribution, and even more importantly, this very complicated distribution in a simpler way. And so we like to use the area model to kind of help us do that. Good luck to you. If you want more practice with this, please come see me and let me know. Thanks. Have a great day.